I'm Bob Vitale, CEO of Midwest Industrial Supply. I want to share with you laboratory test data that compares the performance characteristics of our EK35 with water and with temporary dust palliatives. EK35 is one of the products that we manufacture that creates our semi-permanent runway surface, which produces both runway surface preservation and the longest runway life cycle performance. To quantify the differences between EK35, temporary dust palliatives, and water, we are using test results performed by the most diverse and scientific engineering organization in the world, the U.S. Army Corps of Engineers. The Army Corps of Engineers tested the resistance to surface erosion and to the reduction of dust emissions for 12 different products. And we are going to show you that test results for EK35, for water only, and for a temporary dust palliative. The test data will quantify the actual effectiveness and relative performance differences between these three different methods for runway surface management. That is between EK35, temporary dust palliation, and water. The competitor product tested here is Durasoil, which represents temporary dust palliative products that are not manufactured with a binder system but are fluid-only type products. Matt Medford, our soils lab manager here at Midwest Industrial Supply, will be presenting the data of the Army Corps testing. We believe this data is irrefutable proof of the long-term preservation difference and value of EK35 in place of low-priced products such as temporary dust palliatives and water. Matt?
Hi, I'm Matt Medford, Soils Lab Manager here at Midwest Industrial Supply, and I'm going to be presenting some data that the U.S. Army Corps of Engineers collected on dust palliative performance. I hope you find this information informative and helpful. Independent laboratory testing of EK35's semi-permanent runway preservation versus water and short-term temporary dust palliatives. This study was conducted by the U.S. Army Corps of Engineers in September of 2010. Project title, Abatement Products for Expedient Helipads. The scope of this study was to perform laboratory testing to evaluate and compare the performance of different dust control products under simulated helipad conditions. Data from the laboratory testing was used to determine the most effective products and application rates. During this study, two types of data were recorded and evaluated. First was the product's ability to resist surface erosion under simulated flight conditions. Second was a product's ability to reduce dust emissions under simulated flight conditions. Sample preparation. The test specimens were prepared in 6-inch by 6-inch by 2-inch deep square molds. The soil used was a poorly graded sand as classified by the Unified Soils Classification System. All test specimens were sprayed topically with dust palliatives at application rates of 0.4 gallons per square yard, 0.8 gallons per square yard, and 1.2 gallons per square yard. 3 duplicate specimens were tested for each application rate. After topically treating, the specimens were allowed to cure for 24 hours under infrared lamps. Specimens were tested in an enclosed air impingement chamber where they were subjected to 150 mile/hour winds. Air blasts were initiated 1 inch above the specimen's surface and at a downward 20-degree angle. Additionally, during testing, sand was injected into the airstream to increase surface abrasion and simulate conditions during aircraft landing. Evaluating resistance to surface erosion. Samples were evaluated on their ability to resist surface erosion under simulated flight conditions. This was accomplished by weighing the sample prior to testing and after testing. The amount of soil removed from the surface during testing was considered an indication of how well the product would perform. The less soil loss during the testing means the better erosion resistance. As you can see in the chart, EK35's performance is unmatched by Durasoil. This is true even when 3 times the volume of Durasoil is used. At an application rate of 0.4 gallons per square yard, EK35 had a reduction in erosion of 98.1% when compared to water only. Durasoil, at 3 times the volume and an application rate of 1.2 gallons per square yard, had a reduction in erosion of 82.5% when compared to water. Reducing surface erosion generated from aircraft traffic is vital to preserving the as-constructed state of the runway. Aggregate is costly, especially in remote areas, so extending the life of the runway is high priority. By reducing the amount of surface erosion, costly aggregate overlays can be pushed back by years, therefore lowering the life cycle cost of the runway considerably. When using a synthetic fluid with a binder system, such as EK35, lab testing shows that it reduces erosion by up to 98%. This reduces and can even eliminate routine runway maintenance, such as grading and repairing of damaged surfaces. Evaluating the reduction of dust emissions. Dust concentrations within the testing chamber were recorded using a dust monitor. Measurements of dust concentrations were recorded at 1-second intervals. Data was collected during the 30 seconds of air impingement and 120 seconds subsequent to the air impingement to observe the rate of settling dust within the test chamber. The lower the average optical concentration achieved during testing equates to better reduction in dust emissions and performance. EK35, at an application rate of 0.4 gallons per square yard, provided a reduction in optical concentrations of 96.2% when compared to water. Durasoil, at an application rate of 1.2 gallons per square yard, provided a reduction of optical concentration of 87.4% when compared to water. Reducing dust emissions generated on the runway is critical to the safety of pilots and aircrafts. When dust emissions are lowered by 96%, as seen when using EK35, the life of the runway will be extended significantly compared to untreated runways and runways treated with other dust palliatives that do not contain a binder system. The binder system used in EK35 uses adhesive and cohesive properties to lock the fines into the surface and keep them from becoming airborne during takeoff and landing. Dust emissions pose serious health risks to adults and children living in nearby communities. In addition to this, dust can have severe negative impacts on the surrounding environment and wildlife. As you could tell by this chart, which compares the performance of EK35 to Durasoil, you could tell EK35 at an application rate of 0.4 gallons per square yard compared to Durasoil at 3 times the product volume and an application rate of 1.2 gallons per square yard. EK35's performance is superior to Durasoil in both the reduction of surface erosion and reduction of dust emissions. Based on the results achieved by this testing, there is a significant difference in the performance of EK35, a synthetic fluid and binder system, compared to fluid only, such as Durasoil. In both types of testing performed, EK35's performance is unmatched by fluid only, even when 3 times the volume of fluid only is used, as determined in laboratory testing by the most diverse scientific and engineering organization in the world. This third-party testing provides a background supporting data which proves EK35's ability to deliver long-term, semi-permanent runways compared to short-term, temporary dust control delivered by fluids without binders and water. For the complete report, please visit the link below.